use the method of Lagrange multipliers to find the maximum and minimum values of this function with this given constraint. So here we have f, and from this constraint we find g. So here g as a function of x, y, g. Just make right hand side 0, bring 1 to the left side, so x fourth plus y fourth plus g fourth minus 1. Next we want to find gradient of f and gradient of g. So this is a function of 3 variables, so fx, fy, fg, that is find with respect to x, 2x, 2y, 2g. Similarly, gradient of g is just gx, gy, gg, which is with respect to x, 4x cubed, 4y cubed, and 4g cubed. Using the Lagrange multipliers, we said the following: gradient f equals lambda gradient g, and this constraint. So this is same as, that is 2x, 2y, 2z equals lambda times 4x cubed, 4y cubed, 4g cubed. That implies first component equals first component. We can distribute lambda inside, so we get 2x equals lambda 4x cubed, 2y equals lambda 4y cubed, and 2g equals lambda 4g cubed. Okay, from these we get lambda equals, from the first, lambda equals 2x over 4x cubed. Okay, do not cancel x, because x could be 0, then we cannot cancel 0 over 0. From the second we get lambda equals 2y over 4y cubed, so this is same as 2y over 4y cubed. This is also lambda from second equation. And from third we get 2g equals 4g cubed. Okay, and we have one more equation that's coming from the constraint here, so we will be solving this along with this. Solve this to determine x, y, and g. Okay, that's the goal next. And from here what we do is, lambda, we don't have to determine the value of lambda. Let's take first two ratios. Maybe let's take first and third. So express x in terms of g, do the same thing, express y in terms of g. Once we have x and y, go back and plug in here x in terms of g, y in terms of g, then we'll have only one variable g, and we should be able to determine that value. Okay, so from here, taking first and third, we have now 2x over 4x cubed equals 2g equals 4g cubed. In fact, cross multiply, 2 times 4, 8, so cancel this, but do not cancel x, because you'd lose the values. So it's xg cubed, or this way, doesn't matter, x cubed g equals xg cubed. Bring this to the left side, then this will be negative, then we can factor xg out from these two terms. This leaves x square minus g square equals 0. Now this implies, look at here, we have couple of factors, either x 0 or g 0 or x square minus g square equals 0. That means x equals plus minus g, because x square minus g square equals 0. Move g square over and take a square root, you get this. So this is from first and third ratio. Similarly, if we take second and third, okay, if we just consider this, we're gonna get y equals 0, or g equals 0, or y equals plus minus g. Okay, now we will use these x, y, z values, go back to the top, that's the constraint here, and find x, y, z values. Okay, now let's use these x, y values. X equals 0, y 0. So in the constraint, okay, recall the constraint, that's x to the fourth plus y to the fourth plus z to the fourth equals 1. That's the constraint. When we use x0, y0, x0, y0, so 0 plus g fourth equals 1. Okay, that implies g fourth equals 1. Take square root twice, we get g equals plus minus 1, and there is plus minus I, imaginary number, disregard those. So when x0, y0, we get plus minus 1. Thus there might be more than one point, so point is, we just found points impact, x0, y0, we get g plus minus 1. Okay, and similarly we can find other points. If we take x0 and g0 here, x and g0, we get y value. So that is x0, g will be plus, sorry, y will be plus minus 1, g0. And we also find when we take y0, g0, x will be plus minus 1. Look at, these are just symmetric kind of 0, 0 plus minus 1, 0 plus minus 1, 0 plus minus 1, 0, 0. Okay, and finally we need to consider this, x is plus minus g and y is also plus minus g. Using these points, okay, and go back here and plug in x equals plus minus g, y equals plus minus g. So g to the fourth plus g to the fourth, and g to the fourth equals 1. 3 copies of g to the fourth equals 1, divide by 3, so g fourth equals 1/3. So take a square root both sides, g square equals plus minus 1 over root 3. Take one more time, so g equals just for plus, because for negative, square root of negative is imaginary number, so we don't care about that, plus or minus 1 over square root of 3, square root of square root of 3, so that's fourth root of 3. Okay, this is fourth root of 3. Now then the point is here, from this we get a point. Okay, x is plus minus g, so this is plus minus 1 over fourth root of 3, because x is plus minus g, y is also plus minus g, plus minus 1 over fourth root of g, and g is plus minus 1 over fourth root of 3, not fourth root. Okay, fourth root of 3. So in this way we got a bunch of points here. Okay, all those points are here, 0, 0 plus minus 1, 0 plus minus 1, 0, plus minus 1, 0, 0, and here plus minus 1 over fourth root of 3. Now we plug these values into the objective function to determine the maximum and minimum value. Okay, let's do that. Plugging these values into the objective function, which is fx yz. In fact, f is a function of x and y and g. Okay, fx yz. So the points are plugging in all those plus minus, or 0, 0 plus minus 1, 0 plus minus 1, 0, or plus minus 1, 0, 0. So we're going to get all values like this. Okay, let me put those 0, 0 plus minus 1, 0 square, because the x square plus y square plus g square plus minus 1 is square, just 1, 0 plus minus 1 0, it will be 1. F plus minus 1 0 0, also 1, and we have one last point, f of 1 over 4th root of 3, 4th root of 3, 1 over 4th root of 3, 1 over 4th root of 3 squared, so 1 over root 3. If you square this, you get 1 over root 3, 1 over root 3, 1 over root 3. Okay, so 3 copies of root 3, and 3 is, by the way, root 3 times root 3, so 1 copy of root 3 can be cancelled, root 3. So look at here, I mean, we got 1 1 1 and root 3. So out of these 4 values, root 3 is the maximum and 1 is the minimum. So max value is root 3 at this point, and min value is 1 at bunch of points here. Final.